This is part 3 of the series Transformations, and in the last part we worked an example using reflections, and we reflected a triangle across the line y equals 0, which was the x-axis. This time we're going to use the same triangle, PQR, but we're going to reflect in the line x equals 0. So x equals 0 is the vertical line, which is the y-axis. So we're reflecting this way now. So let's go ahead and plot our points. So we have 3, 1, 5, 1, and 5, 3. Draw our triangle in. So there's our triangle. Now what we want to do is we want to move these points along a line that's perpendicular to the line of reflection. So just for kicks, let's go ahead and put in a line that's perpendicular to this. So let's go here and let's draw in a perpendicular line. Difficult to see there. That's a little better. Alright, so now what we're going to do is we're going to move this along this line a distance equal to the distance this point is from the line of reflection. 1, 2, 3. So we're going to go along this line 1, 2, 3 units. So let's go ahead and put that point where it needs to be. It's going to be at -3, 1. And we're going to do the same thing with this point. This point is 5 units away from the y-axis. So 1, 2, 3, 4, 5. So the point goes out here. And this point is 5 units, but it's at y equals 3. 1, 2, 3, 4, 5. And we can draw in our triangle just to exemplify the final image. And so now we have reflected triangle PQR in the line x equals 0. Now let's take a look at what happened to these coordinates. So we're going to use this one as the basis. So this coordinate is 3, 1. And what happened here? Well, this coordinate became -3, 1. This one was 5, 1. This one became -5, 1. And 5, 3 became -5, 3. So what happened between here and here? Well, you can see that each one of the x coordinates went negative. So the transformation notation for a reflection in the y-axis is given by x, y goes to -x, y. The x goes negative, the y stays the same. So this is a reflection in the y-axis. Alright, let's work one more example just to solidify these ideas. In this example, we're using the exact same triangle PQR here, but this time we're going to be using the line y equals x as our line of reflection. So as usual, let's go ahead and write in our triangle. So it's 3, 1, 5, 1, and 5, 3. Okay. Now, the line y equals x is going this way. So let's go ahead and put that in. And what we're going to want to do next is translate each one of these points along a segment perpendicular to the line of reflection. And that way it will reflect this figure across that line. Now, one of the ways we can do that is we could go through the hassle of actually drawing in the line and calculating this distance using Pythagorean theorem and all that stuff, but there's an easier way. Notice that if we go over to the left 1 and up 1, we get to the line of reflection. Therefore, if we go over one and up one again, we will be the same distance, because this horizontal component is the same as this horizontal, this vertical is the same as this. So these two triangles are the same triangle. Therefore, that hypotenuse is the same distance. So, over one, up one, over one, up one. Same thing with this one. 1, 2, 1, 2. And this one, over one, up one. So we've got a way that we can move these along perpendicular lines without actually having to find this distance from here to here, from here to here, and from here to here. So let's go ahead and put in our points. So it's going to be 1, up 1, over 1, up 1. So it's going to go here. And here it's over 2, up 2, over 2, up 2. And here, over 1, up 1, over 1, up 1. And let's go ahead and draw in this triangle. And just for kicks, let's put in the perpendiculars here. And we can see that this point, in fact, moved along a line perpendicular to the line of reflection. So did this one, and so did this one. So we've done what we accomplished. Now let's put in our coordinates here and see what we've got. This one went 3, 1, and it went to 1, 3. Well, that's interesting. Then we had 5, 1, and 5, 3. And this one went to 1, 5. And this one went to 3, 5. So as we can see, what ended up happening here was the coordinates swapped places. Hopefully you'll recall from the previous series that when we calculated slopes of lines perpendicular, we got negative reciprocals of each other. So this line has a slope of 1, this line has a slope of negative 1. Well, that idea of perpendiculars meant that the x and y swapped places, and that's exactly what we've got in action here. So let's go ahead and look at the transformation notation for reflection in the line y equals x. And what happened was x, y went to y, x. So the y became the x became the y. So they just swapped places. While we're here, let's go beyond a reflection in the line y equals x, and let's see what happens when we reflect in the line y equals negative x. That's this line going through here. Let's go ahead and put in that line to see what we're talking about. And what we want to do at this point is we want to move these points along lines that are perpendicular to this line. So let's go ahead and put in those perpendicular lines just for clarity's sake. And now we can do the exact same thing we did moving across y equals x. We determine how far this point is from here. So we've got to come down 1, 2, 1, 2. So it's going to come down 1, 2, 1, 2. This one, 1, 2, 3, 1, 2, 3, and then down 3 and over 3. And then this one is going to come down 1, 2, 3, 4, 1, 2, 3, 4. Now, sometimes an easier way to do it is to start from the intersection of the perpendicular to the line of reflection, and it's a lot easier sometimes if you can't see the count in your head. 1, 2, 1, 2. Here from this point it's 1, 2, 3, 1, 2, 3. And from this one's still going to be a little harder because we don't have a clean intersection point down here. So you're better off just going back to this method. 1, 2, 3, 4, 1, 2, 3, 4. We've got to be along this line. So it's 1, 2, 3, 4, 1, 2, 3, 4. All right, let's go ahead and put in our points and do our transformation, which is a reflection in the line y equals negative x. So here we said it's 1, 2, 1, 2. Then we go down 1, 2, 1, 2. So there's the new point. And here it's 1, 2, 3, 1, 2, 3. Then we go down 1, 2, 3, 1, 2, 3. And there's that point. And then this one is going to be 4. So it's 1, 2, 3, 4, 1, 2, 3, 4. And we do it again to move along this line. So 1, 2, 3, 4, 1, 2, 3, 4. And there's our point. And we put in our triangle. Bad triangle. But you get the idea. So now this triangle has been reflected across the line y equals x. Let's now take a look. I'm going to change colors again because I won't be able to see that very clearly. Let's take a look at these new points here. So this point down here is -1, -5. This point is -3, -5. And this point is -1, -3. So let's take a look at what happened here. This point went from 3, 1 to -1, -3. 5, 3 to -3, -5. And 5, 1 to -1, -5. Do you see what happened? It's the same pattern. The x's and y's swapped places, but this time they swapped places and changed signs. So a reflection in the line y equals -x is achieved by xy going to -y, -x. And that's a reflection in the line y equals -x. So let's take a look at a summary of these transformation reflection rules. In the first one, we reflected across the x-axis. So we moved point A along a line perpendicular to the x-axis, and we can see that the x-coordinate stayed the same, and the y-coordinate went negative, so y went to -y. When we did a reflection in the line in the y-axis here, point A went along this perpendicular line. And so we see that in this case, the x-coordinate went negative and the y-coordinate stayed the same. So x went negative and the y-coordinate stayed the same. A reflection in the line y equals x yielded us a swap of the x and y's. So the x went to y and the y went to x. So x went to y, the y went to x. And then the reflection in the line y equals -x. We see that the x became the y and went negative, and the y became the x and went negative. And so a reflection in the line y equals -x yielded us x going to -x, x swapped to the y swapped to the x, and they both changed signs. Alright, that will wrap up this part of the series, and in the next series we're going to look at something called symmetry. So I will talk to you in the next part.